quick, I'd like to just review because since we're having a quiz next Wednesday, we have Monday off. Next class, we're going to have a quiz on 6D and E. I just want to real quick remind ourselves of what we did last class, just to kind of get an idea, just to see if we remember what we would do here. Okay? First of all, how do I know I need to use trigonometry at all in this case? What's true? There's two things I have to check for. One of them is what, Alyssa? I have sides and angles in a right triangle, right? I have a combination of sides and angles. What tells me that I need to do the inverse? So Martin, this is definitely for you because you weren't here last class, right? So what tells me I have to do the inverse trig, Jay? Right, the variable, the x, is what the angle is. We're trying to find the angle. So we know we're going to do inverse. We just don't know which one yet. So I need to label both the 7 and the 4 as either the opposite, the adjacent, or the hypotenuse. So looking at the 4, what would you label that as? O, H, or A? Good. It's across from the angle x, so that's our O. And what about the 7? H, the hypotenuse. And so knowing SOHCAHTOA, we remember this, which I've been finding an awful lot written around the room, in folders, on desks. If I catch you writing on the folder or the desk at this point, we're going to have a discussion about what that means. So please just make sure that you are not, if you see it on your folder, you need to tell me, okay? Because I don't want you to be in a situation where that happens. But anyway, it's SOHCAHTOA. So looking at this, SOH is which one? Sine. Good, Danny. So it's going to be the sine of what? Well, since we're trying to find the angle, can't we just go ahead and write inverse sine if we want? You can do this if you are, that's perfectly okay. But I am okay if you go ahead and just jump right to this. Does that make sense? It's okay since you know it's an angle if you want to start just with the second step. I'm okay with that, all right? But either of these is fine. And then you just type it into your calculator. Double check your mode. Go ahead and tell me what the degree measure would be here. This is just a little warm up, a little background. Make sure you have your right mode. Inverse sine of 4/7 would be how many degrees? What'd you get, Tatiana? 34 point, I can't hear you. Thank you. 34.8. Is it 9? Okay, 34.9. Does that seem reasonable to you? What's the biggest angle I could possibly have? Well, not quite 90. It has to be a little bit less than 90, like 89, right? Because you have to have two of these angles that add up to be 90, right? So it does seem like a reasonable answer. So we're good. Awesome. Any questions? Use inverse when we're trying to find the angle is basically the key. So we're going to do a little bit more with both regular trig and inverse trig today. We're going to do it all in application, so real world examples. It's a lot of word problems, but we're going to be learning how to draw the picture is really the hardest part, and figuring out where the x goes and where the numbers go. But before we get to that, we have to define two different things, both angle of elevation and angle of depression. So don't write any of this down quite yet. I'll tell you what I want you to write down. But let's look at and think about what does elevate mean. What does elevation mean? There's a couple of different meanings in the English language for elevation. Anybody know what an elevate, what that would mean? Elevate or either way. Okay, to better, that's one. Okay, so to get, let's start with your first one. To better yourself, to elevate a situation, that would be one meaning. Yep, so did you have your hand up, Sabellas? To raise, I like that, to raise up. Well, I don't know about balance, but I definitely think that going up, think about an elevator, right? An elevator is something that rises up, would you agree? So I think we're going to stick with that kind of meaning for us. It means it's kind of going up, okay? So knowing that, let's go ahead and define what it means mathematically, okay? So mathematically, the angle of elevation starts from a horizontal, some horizon. Often it's the ground, but sometimes it can be up in the air, kind of like a visual out in your, from an eyesight, but it starts from a horizontal, and from there it goes up. So the angle of elevation goes up like this, okay? So from a horizontal up, angle of elevation. When you think about the word depression, depression also has several meanings. Give me some idea of what you think of depression means. Okay, sad, down. When you depress a button, have you ever heard that word? When you depress a button, what does that mean? You're pushing it down. Would you agree? So angle of depression, again, starts from some horizontal. Often it's up in the sky, and it goes down from there. So angle of depression goes from a horizontal down, okay? So angle of elevation goes from a horizontal up, and angle of depression goes from a horizontal down. Do we have those two definitions? Good? All right. So let's look at this example here, and then you're going to try one on your own. Let me make it a little bit bigger so you guys can see it. Kind of hard to see. There we go. So I have a hot air balloon, okay? Oops. There we go. I have a hot air balloon and a mountain in my picture. And I want us to think about angles 1, 2, 3, and 4, and whether or not they're angles of elevation or angles of depression. What do you think about angle 1? It is depression. It's from some imaginary horizontal line up in the sky, but it goes down. Don't you agree? Angle of depression. So angle 1 is an angle of depression. I agree. What do you think about angle 2? That's an elevation. Again, still from a horizontal. It is imaginary up in the sky, but from there it does go up. So that's an elevation. What do you think about is true about the measures of angle 1 and 2? Why? Not opposite. There's a word. We learned about it a couple months ago. Alternate interior angles. Those are parallel lines. So yes, I agree. These particular angles are congruent. True. What kind of an angle is angle 3? Elevation or depression? That's depression. Again, it's going down. Do you agree? Perfect. And then how about angle 4? That's an elevation. All right, perfect. So what I'm going to do is I'm going to pause the recording for just a second, and I'm going to ask that you, I'm going to pass something out, and I want you to do the first 8 problems. And literally, it's just, is it depression or elevation? You're just making that decision, nothing more than that, okay? All right, so I agree with your answers. Looks good. We understand the difference between elevation and depression. Awesome. So what I'd like to do is I'd like to jump into how we can use this idea to help us draw a right triangle to solve a problem, okay? So this is example 1 that you should be putting in your notes. Go ahead and put that other sheet just to the side for me for just a second. We have example 1. This is 6E. That's what's on the board. Sure is. And Chris and Juliet, since you guys just came in, we are having a quiz next class on both 6D and E, okay? All right. And by the way, retakes for, bless you, honey. Oh my goodness. That's the cutest sneeze ever. Retakes for any of Unit 6 is next week, so we're going to be closing the window for that coming up shortly. So just make sure that you make arrangements with me sometime next week. I think Tuesday we have Flex 4-5. Either of those are okay to come and retake during, so you can, see me for a pass to do that if you'd like to do that on Tuesday. All right, so you don't have to write the problem down if you don't want to, but it's a good idea. To me, the most difficult part of this type of problem is being able to read the question and know how to draw the triangle. So when we look at this question, it says that I spot a rock climber at a 32-degree angle of elevation. So knowing how we're going to draw an angle of elevation, that should be our clue on how to draw the triangle, okay? So that's what we're going to do. So let's draw our triangle with an angle of elevation, like this, okay? And we have 32 degrees in our angle of elevation. We'll go ahead and finish off the right triangle. Make sure it's a right triangle. And you can kind of imagine that I spot it here. This is me, and here's my rock climber. We okay with that? Rock climber's somewhere up here. I'll put an R for rock climber. He's up in the sky, up on the cliff, right? Let's keep reading. All we read so far was 32-degree angle of elevation. Let's keep reading and add to our picture. It says your eye level is 6 feet above the ground. So I'm going to put this over here as 6. Are we okay with that? Just off to the side. It's 6. Okay. It says that you are 1,000 feet from the base of the cliff. Where does the 1,000 go in my triangle?
No.
It's not the height. It's from the base of the cliff. That's right. So it's across the bottom. If it says things like across the river or from the base, that means that it goes here. Okay? So when you're reading these problems, you have you want to make sure that you're knowing where to put the numbers. Where the numbers go is essential, because if you put it in the wrong spot, you're going to get the wrong answer. Okay? So that's really key. Then the last part says, what is the approximate height of the rock climber from the ground? So where does my X go? So it goes on the right side of the triangle, correct? It goes here. Are we okay with the picture? Every sentence gave me a different piece to my picture. Do you agree? So it's important to, as you're reading, label your picture. The key is where the angle of elevation told me how to draw the triangle. If it was an angle of depression, we would draw it like this. And this would be the angle of depression from there down. Okay? Are we okay with that? So angle of depression, angle of elevation. Good? There's really two scenarios. All right, so what do you think, now that we have a picture, what do you think that our next step would be? I can't solve yet. Label our sides. Perfect. I need to label the X and the 1,000 as either my O, my H, or my A. What do you think the X is going to be? Okay, it's the opposite of my angle. And what about the 1,000? That's my adjacent. Perfect. Now, am I going to use inverse trig or regular trig? Because I have the angle, right? I don't need to find the angle. So that's not inverse, that's just regular old trig. Which trig function using SOHCAHTOA am I going to use? Tangent, perfect. So tangent of, put my angle in there, good, is equal to, and we have a fraction here. What do you think? X over 1,000, perfect. So what do I do to solve it? Alyssa? Multiply by the denominator, which in this case is 1,000. Very good. When I multiply by 1,000, it cancels over here, with leaving me with just the X, which is what I wanted. And now I can just type into my calculator 1,000 times the tangent of 32. All right. That's reasonable. What'd you get? 624.9? Does that look right? I'm here to tell you that that's not the answer. I want you to read the problem again. Look at the picture and read the problem again and kind of decide, what piece of information haven't I used yet? The 6. So if you want to kind of envision this, I have my person, and I've done this kind of imaginary triangle out in space, out from my eye. I see the rock climber. Well, I have found only this height. 624 is only this. I need to find the entire height. So what do you think I need to do to that 624.9? Not multiply by 2. I don't want to multiply by 6. Well, here, let me put numbers to it and see if that makes sense. If this is 624.9 and I need to find this, and I know that this height is 6, what would I do with those two numbers to get the total? Add them. So I'm going to add 6 here, and what do I get? 630.9. And what was the, I believe it's feet. Is that correct? Let's double check. Yeah, it was feet, right? So we're going to put our units here. Feet. How do we feel about that problem? It's our first go. I think we need to do a couple more and practice, don't you? Drawing the picture is the hard part, okay? I agree. Drawing the picture is hard. I think we need to practice that. So let's try another one, okay? Let's try another one where we have to draw the picture. So this time we have an airplane. Where are airplanes usually? Okay, so we're up here. And that probably means we're going to talk about an angle of depression, don't you agree? Because we're starting up and we're looking down. What do you think? Is that what it says? Yeah. So we have angle of depression, which means what does my triangle look like? Doesn't it look like this? Angle of depression. I see the words angle of depression, so I know I'm drawing my triangle down. Okay? Where does, and it's spotting a life raft, and we have an altitude. Well, let's just take one piece of information at a time. Starting at the beginning, I see 26 degrees. Where does that go? Angle of depression means I'm up here and I'm going down. So look at the triangle. Isn't it the top left angle? It's right here, 26. That's where angle of depressions are. They start here and they go down. Okay? Keep reading. The airplane's altitude is 3 kilometers. What is altitude? It's the height. Okay? So where does that, how is that labeled on the picture? Annalise? Did you have your hand up or are you just kind of stretching? No. Okay. Anybody want to guess? Where does the height go on the triangle? Kiana? On the right side. Yeah, this is the height. So this is going to be my 3. That's how tall, if you want to think about it that way, the triangle is. The height. Okay. Let's keep reading. What is the airplane's horizontal distance from the raft? Well, if we wanted to kind of be cute, we could draw a little airplane. I don't know. I'm terrible at airplane drawing. We have a little life raft, right? Whatever. We have water, since it's in the water, whatever. We can draw fish, I don't care. But the important part's a triangle, would you agree? Where is X? Read the last sentence one more time. So here is a very key word. Horizontal means kind of like across, don't you agree? It's the flat part. So horizontal distance is going to be here. Okay? When you see things like across, from the base, horizontal, those all kind of refer to the same part of the triangle, the flat part. Yeah? What if the question was different and it said, what is the distance in the line of sight from the airplane to the raft? That would be the hypotenuse. How far does the airplane have to fly to land on top of the life raft? That wouldn't make sense, but the airplanes fly at that hypotenuse too, right? Line of sight, between things, sometimes those refer to the hypotenuse. But horizontal distance, definitely what you see here, okay? So we have our picture. Again, Daisy, the hardest part, right? What now? Okay? So what's the X? Adjacent. Good. What's 3? Opposite. It's not the hypotenuse, it's the opposite. We have another tangent here. Do you agree? Yeah. Another tangent. Is it inverse? It's not inverse. Kevin says no because already have the angle. We don't need to find it. Perfect. So I know it's the tangent of my angle is equal to, what's it equal to? 3 over x. Now this is where some people had some problems on their quiz. When the x is in the denominator, we have a little bit different algebra. We're still multiplying by the denominator, but the denominator this time is x. You are going to eventually divide tan. That is correct. So you're going to multiply by x. That gives me x times the tangent of 26 is equal to 3. And then Anaya's right. The divide by the tangent of 26. If you are to the point where you are savvy enough to go straight from your original equation, knowing that the x is in the denominator, you can just switch these two and get down here. This just happens to be the algebra to get there. Okay? Do you remember how to type it into your calculator? You got to have a fraction. Where do you find the fraction on the calculator? Alpha y equals. Beautiful. You definitely want to do that. So we're going to say alpha y equals, and we're going to type it in. 3, arrow down, tangent of 26, 6.15. What are my units here? It's not feet. It's kilometers, right? How are we doing so far? The picture's the hardest part. Keywords: horizontal distance, altitude, line of sight. Those are keywords that help us figure out where they are. So maybe we need to add that to our picture. Okay? We have the horizontal. We have the altitude or height. Here we have line of sight. Those are key words that help us figure out how to label where the numbers or where the x goes. In this picture, do I have an angle of elevation or an angle of depression? Elevation. I have elevation. And where does the, I kind of flipped the picture a little bit, but the elevation is here, don't you agree? From the ground up, angle of elevation. I just flipped the triangle over, that's all. Keywords. Yeah? No question. Yes. Otherwise, you wouldn't know where to put the angle. Yes. Good question. Yes. Oh, that's a good one. Let's put that on there too. Across from the base. So from the base. Is this one too? Across. Is that one too? Yes. All good words. As we do more of these problems, we can add to the picture about where the words go. Okay? I like that. Perfect. All right. I'd like to try at least one more, and you don't have to write this one down. I'll give one more that I want you to write down, but not this one. Okay? So this one you don't have to write down. Let's just look at it. So I see Rachel has spotted her car from a weather balloon. Where are typically weather balloons? In the air, in the sky. So we're probably talking about an angle of depression, right, Martin? Yeah, okay. Angle of depression. How do I draw my triangle for my angle of depression? I'm looking at what you're drawing. Beautiful. That's exactly right. Angle of depression, we're up in the sky and we're going down. Let's keep reading. She knows her altitude is 82 meters. Do we know how to draw the altitude? Okay, I want to see that. And then her angle of depression, perfect. She wants to know how far she is from her car. How far she is from her car. So if I'm thinking about drawing a picture, so far we have a balloon. We have an angle of depression. Are we okay with why x is where it is? It's kind of like the line of sight, right? How far she can spot her car. She sees her car. It said that in the problem, didn't it? So that is how far she is. If it said, what's the horizontal distance, the x wouldn't be there, would it? So this is the picture. What trig function would we do? Are we okay with Wyatt's sign? Opposite over hypotenuse, right? Okay, good. Is it inverse or regular? Okay, good. Here's one that I want to do, and I want you to write this last example down. So this is example 3. And this one's a little bit different. Example 3. So Miss Mackert doesn't have a porch. She's always wanted a porch, but so I'm going to pretend like I'm sitting on the porch, okay? I don't have a porch. Huh? Oh, a Porsche? Actually, the other day I was driving to work and 2 Porsches drove by me on the parkway. And I was like, yeah, okay. You have a Lambo? A little one, like a little Matchbox one, like this big? All right, so I'm sitting on my porch, and I spot a bird 15 feet away in a tree that is 12 feet tall. What is the angle of elevation to the bird? I'm going to pause the recording. I want you to attempt to draw the picture yourself, labeling the numbers and X on the picture. So I think this question is a little difficult in terms of wording because of where the 15 goes, okay? So we know because it says angle of elevation that we're going to draw a picture that has an angle of elevation. Do you agree? And we're trying to find the angle of elevation, so that's where the X goes. Martin, I'm going to need you to wake up and focus with me, sweetheart. You were absent last class, too. If the tree is 12 feet tall, most of us got that tall, how high it is, that's going to be over here. Perfect. The tricky part is that she spots a bird 15 feet away. It doesn't say that she's 15 feet away from the base of the tree. It doesn't say she's horizontally 15 feet away from the tree. It says she sees it 15 feet away. Do you agree? So to me, it's kind of tricky about this problem, but I read it as 15 should go here. Her line of sight is 15, okay? If she was 15 feet away from the base of the tree, then 15 would be on the bottom, okay? I'm sorry, what, sweetie? Exactly, that's why it doesn't go there. Perfect. Are we okay with the picture? All right. So what trig function are we doing? Which is inverse sine. Very good. I am okay. So we know it's sine because we have opposite and hypotenuse. So, and we know we're finding an angle. I am perfectly okay if you just go ahead and type this in straight from here. We know it's inverse sine because we're trying to find the angle. We know that sine is opposite over hypotenuse, which is why we have 12 over 15. And then at this point, you're just typing it in, making sure that you're in the right mode. What is the angle of elevation? What'd you get? 53 degrees? 53 point what? 0.1? One or two decimal places is good. Don't please, I know the directions on your paper are going to say round to the nearest whole degree or whatever. Don't do that. Just 1 decimal place is fine, okay? I'm good with that. What, honey? Oh, yeah, it's actually degrees because it's the angle, right? So not feet, but we're looking at what we're trying to find, so it's actually degrees, okay? So you guys have several things to work on at this point. Starting with problems, please listen. Problems 9 through 12, the pictures are already there. Awesome. You don't have to do the picture, they're there. It's literally just solving the problems. Please turn your paper over for me. There was a misprint. These problems aren't numbered, first of all, so they should be numbered 15, 16, and 17. So go ahead and label those 15, 16, and 17. And the picture that's underneath 15, I don't know why it got copied there, but cross it off completely. The picture doesn't make any sense. It doesn't go with the problem at all. You have to redraw the pictures yourself, okay? Now, problem 17 is a little rough. So I'm going to let you guys work for a little bit, and then I'm going to come back in a few minutes, and we're going to talk about the picture on 17, okay, because it's a little bit harder. But go ahead and work on the others for now, and we'll come back. Okay, this is the last problem. I kind of just typed it up real quick and put it up here, and I wanted us to be able to look at how to draw the picture here. So Kelly wants to find the distance across the pond. We have an angle of elevation, so I'm going to draw the angle of elevation, and I want to find the distance across the pond. Do we agree with that part so far? Okay. We have that the height of the tree on the other side is 27, but we have 18 degrees as our angle of elevation. But we also have a tripod. In case you don't know what a tripod is, it's just a stand that has 3 legs. It like holds cameras and things like that. Yep. And so what we need to think about is the 27 and the 3. You agree that this height here from the tripod to the ground is 3 feet, right? That's the 3. Her tripod's 3 feet tall. 27 is from here all the way down. Would you agree? Not just the triangle, but all the way from the top of the tree all the way down. So what number on the triangle are we actually going to use? We're not going to put a 27 on there. It's 24 because you have 3 feet from here to here. So we need to subtract those 2 numbers and use the number 24 in our triangle. So the actual triangle that we're going to use is 24x and then 18 degrees. I just wanted to make sure that we talked about that because in the previous problem that we did, we added 6, right? But this one we're actually doing some subtracting, so a little bit of a different scenario.